This is Florida Gulf Coast University.
Well, we're out sampling sharks. We are going to be satellite tagging 3 species of shark, the great hammerhead, tiger shark, and bull sharks. But we'll collect tissues, including a biopsy tissue and a fin clip, a piece of fin clip, from all sharks that we capture. And we're interested in terms of the satellite tagging because it'll actually tell us where the sharks are headed and if they're resident species. I'm interested to know if they're resident species or if they're running up the rivers. Bull sharks, for example, will go up rivers. And that'll give me some information to evaluate the patterns that I see in some of the chemical analyses I'm doing with the tissues. I'm actually running mercury analysis on the biopsy tissues that we're collecting, and I'm going to be collecting and analyzing the fin clips for stable isotopes of carbon and nitrogen. South Florida in particular, but also the Gulf of Mexico, has a serious mercury problem. Right now, in the coastal waters of Florida, there's 59 to 60 different species of fish that are listed for limited consumption, meaning that particularly women of childbearing age and children shouldn't eat eating too much of these fish because of the mercury in their tissues. So we're concerned with better understanding where that mercury is coming from, and so oftentimes it might be methyl mercury coming out of the freshwater system, so we're tracking that. It might actually be methylated by bacteria in the sediments of estuaries, so we're trying to track that. And it also could be methylated out in the pelagic system. And you're going to keep an eye on the water going through the gills. Once we get all those measurements, then we can start taking the fin clip or the biopsy, whichever kind of works in correctly, and we'll put those away and record the date. You don't have to record it right at that moment. You can record it once we get the shark off.
You got to keep the front side out. Stay in the front. He's going down. Let go.
A lot of sharks feed at the apex of the food web. They're feeding very high, and fish that eat other fish, they're going to have more mercury. Fish that tend to eat invertebrates or planktivores, they don't have a lot of mercury in them because they're feeding very low at the trophic food web. But every time a predator is eating its prey, the mercury is being biomagnified up the food web. Not every chemical biomagnifies, actually only a few of them do. It depends on how well it is trophically transferred. Mercury tends to be stored in tissues, the very tissues that everybody likes to eat, including us. They're stored in the fillets of fish. That's why we get the mercury. So one source, a dominant source in South Florida was the incinerators. But we were also very concerned with coal-fired power plants. We don't have a lot of coal-fired power plants in South Florida. We've got some in North Florida, but it's also the global pool of mercury that are being produced by other coal-fired plants, particularly China. China and India have huge amounts of coal. Something that's happening halfway around the world can impact the amount of mercury being deposited locally. And that's what we talk about or see here in Florida, that a lot of our mercury may be coming from someplace else. We do have some preliminary assessment of the data that we've collected thus far, and right now the blacktip sharks appear to have a lot of mercury relative to the other species, even the tiger shark, which kind of surprises us. We thought the tiger, because it is actually feeding a little bit higher, would have more mercury in its tissues, but the blacktip seems to have a lot more mercury than tigers. In this case, maybe the tiger sharks are actually handling the mercury a little bit different than some of the other species. Most of the debate centers around the low-level chronic impacts and, in terms of people that eat fish all the time. Even people that can afford the very best fish, the tuna, the sushi fish, those people are actually getting the higher doses than other people that might be feeding on the less desirable fish like tilapia or, some of the other fish. And so there has been studies done that suggest that even chronic low-level exposure to mercury can cause problems. Even if you're eating tuna fish every day, and there are people that eat tuna fish every day, or they'll eat kingfish a couple of times a week. Those people are being exposed to mercury, and they could actually be resulting in a very subtle change. There was a book written out in California, and they term it fish fog. It's just a little bit of a kind of a hangover feel. Folks out in California are claiming that they're experiencing because they're eating very large amounts of very high quality fish that tend to be fish that eat other fish. Some of these sharks that we're pulling in today will have 3.3 parts per million, quite a bit more than the tuna will. But you know, people, even though they do, some people will continue to eat sharks even though it's on limited consumption advisory. It's the tuna, if you have it 3-4 times a week, you know, as a tuna sandwich or a tuna steak, that's where the concern is. It's how much you have. And so the ideal thing is that we still want people to eat fish, but you got to pick the right fish to eat. And if you like to eat a lot of fish, try to pick fish that don't necessarily eat other fish.
I've been getting a lot of experience here, a lot of opportunities that I couldn't have dreamed of before. It was pretty cool. It was funny because when I was reeling it in, the tension gave, so I thought that it got off the hook, and then all of a sudden it was back, and I saw the shark, and it was huge, so that was my first time actually reeling a shark in.
Come on. The Florida Department of Environmental Protection and the Florida Department of Health have actually issued a wallet card for the species in our waters that'll tell you how much mercury they have in them and also give information about the omega-3s. So you can keep track of the amount of mercury and the amount of fatty acids so that you can do a risk-benefit comparison. They're doing a very similar project, looking for the trophic magnification factor from the invertebrates all the way up to king mackerel. And so we're looking at grouper and snapper, and then we can see how the mercury is being trophically transferred all the way up to like a king mackerel. And it was very interesting because we actually collected a couple of king mackerel out here that had some of the highest mercury ever reported. So we wanted to double check, so we sent a couple of subsamples up to NOAA. They confirmed our results, and we've already presented that data at a conference.